RNA and protein in cells, and with Massimo and Miriam's help in the mouse model, and at Repligen looking at the safety issues of these molecules. And indeed, they've found molecules that have improved efficacy in terms of their ability to inhibit histone deacetylase activity with lower toxicity in cells than our original molecules. So this is good news. The next thing they have to do is, based on all of these results, identify what we would call a clinical candidate. Then full safety profiles and pharmacology profiles of that molecule can be performed. That's very expensive. And once that data is in hand, Repligen can apply to the Food and Drug Administration in the US for an investigational new drug application and then commence a phase 1 trial. I would love to be able to tell you when that's going to happen, but that's now up to Repligen. It's out of my hands. Okay, so this slide just says that we have identified molecules from the Repligen library that are better at increasing frataxin levels than the original molecule that we synthesized. Okay, in the last few minutes, what about other triplet repeat diseases? Well, since you're interested in the spinocerebellar ataxias as well as Friedreichs, I thought I would give you some results from our laboratory with this class of molecules on the related disease, Huntington's disease, which is also a CAG, polyglutamine repeat disease. Huntington's is a very well studied disease. In fact, I've heard that there are more publications on Huntington's disease in PubMed, the Library of Medicine, than there are individuals in the United States that actually suffer from the disease. If that's a believable statistic, I don't know. But that was stated by someone at a recent Huntington's disease conference. Anyway, the protein Huntingtin is known to be involved in transcriptional regulation. That is turning on and turning off of specific genes in the brain. And in fact, mutant Huntingtin sequesters proteins that are essential for gene transcription. And so many investigators have investigated whether histone deacetylase inhibitors might be of benefit in Huntington's disease. An individual at Scripps, Beth Thomas, who has her own laboratory, has a mouse model for Huntington's where 300 CAG repeats are expressed in the first exon, first coding region of the human Huntington gene in a transgenic animal. So this animal harbors just a part of the Huntington's gene and expresses these 300 glutamines and forms toxic aggregates. This animal develops symptoms after about 3 months of age and only lives to be about 6 months. So what we did is we took one of our histone deacetylase inhibitors that worked in Friedreichs and fed it to these animals for, it was about 11 weeks, 10 to 11 weeks, at about 100 to 120 milligrams per kilogram of body weight per day in their drinking water. At the end of the experiment, the animals were sacrificed, slices were taken through their brains to look for neurodegeneration. So this is in this region of the brain called the striatum that's most affected in Huntington's disease. You see this vacuum. In an untreated Huntington's mouse, transgenic mouse, with those 300 glutamine repeats, you see this very large vacuole, indicative of neurodegeneration. If we treated the animals, mock treated them, the control animals still have these vesicles. But those animals that were treated with our histone deacetylase inhibitor had vacuoles that were comparable in size to wild type, indicating that we prevented the gross neurodegeneration. Rather than going into all the technical parameters of these mice, their locomotor activity, grasping, all this sort of stuff, a couple of pictures are worth many thousands of words. So here's a little movie of a wild type mouse, same mouse, but lacking the CAG repeats, lacking the human Huntington's gene. All right? It moves around. It's a happy little critter. As happy as a mouse can be locked up in one of our labs. Here's the Huntington's mouse. You can see it's actually smaller in size, it's hunchback, its coat appearance is terrible, and it's hardly mobile. All right? So you can clearly see that this mouse has a severe phenotype. So that was an untreated CAG repeat mouse. Here's a litter mate that's been treated with the vehicle that our compound is dissolved in. No effect whatsoever in the vehicle. Still a very unhappy, lethargic, badly looking mouse. Here's the mouse after 10 or 11 weeks of treatment with our histone deacetylase inhibitor. In a variety of parameters, this mouse is very similar to a wild-type mouse. There are differences. It has lost a little bit of weight in comparison to a wild-type mouse, but it's not as severe as its untreated litter mates. Just to give you a side-by-side comparison of the wild-type mouse and the treated mouse. They're pretty much the same, aren't they? So we're very optimistic based on this, that these molecules can go forward. But of course, working, as Massimo said, working in a mouse is not the same thing as working in a human being, and a lot more work needs to be done. I'm not going to go into all that. These are the folks that did the work in my lab. Obviously, the Friedreichs work was in collaboration with Miriam and Massimo in Brussels. We've had support from Repligen Corporation, the Friedreichs Ataxia Research Alliance in the United States, the U.S. National Institutes of Health, BOFAR, and Ataxia UK, and the National Ataxia Foundation. And I thank you for your attention.